Last class, we learned about if-then statements, which are just conditionals. And we also learned about converses, where we're flipping the hypothesis and the conclusion. We learned about inverses, where we're just negating the hypothesis and conclusion. And we learned about contrapositives, where we are both flipping the conclusion and the hypothesis, and we're negating both of them. Now, all conditionals are all statements, do not have to be in an if-then format, kind of like we could have a statement saying, I play soccer. And there is a truth value of that for each of you, because think about it. Do you play soccer or not? For me, the answer would be false for that statement because I don't play soccer. But for some of you, you do play soccer, so that would be a true statement. So today we're going to talk about different kinds of statements. We're going to talk about compound statements first, and then we're going to get into truth tables. So when you're talking about a compound statement, you talk about this in English, but today we're going to talk about how we can do this in math. And when we are using a compound statement, we're really just joining two or more statements together using some linking words. And the only linking words that we use in math are the words and or. And the thing is that when you join two statements together, you do it in such a way that the original statement still is really the exact same. And again, you're just linking them together with the words and or. So let's go through some examples. We're given some statements. First, the statement is P, and it says 2 points create a line, which we know it's true. Now, if we look at statement Q, it says 3 non-collinear points create a plane. Again, we know that's true. Now, if we put those together and have P and Q, we're just going to take the two statements as they are and join them together with the word and. So 2 points create a line and 3 non-collinear points create a plane. So again, remember that you do not change the wording of the original statements. You are just linking those original statements with the word and or. So let's differentiate between those two. The first one that we can say is a conjunction is when we're joining two or more statements using the word and. And so we could have P and Q. Now, I want to tell you that the upside down V is our symbol in math for and. So if I'm given the words P and Q, we would write it with P and then upside down V, Q. So that represents the words P and Q. Now, a conjunction is only true when both statements in it are true. So both the P statement and the Q statement would have to be true for the overall conjunction to be true. Now, when we talk about a disjunction, this is when we use the word or. And the symbol for or is like a V, is the symbol for or. So if we're given the words P or Q, the symbols that we would use would be P and then or Q. Now, the difference between a conjunction and a disjunction is going to be true if at least one of the statements is true. So only one of these statements, either P or Q, has to be true for the whole disjunction to be true. So let's talk about this. We've got some statements here and we want to determine if they are true or false. So if I look at this first one, P, it says even numbers can be divided by 3. So I want you to think if that's true or false, and you can pause to come back and take a look at this. I want you to think about all 3 of those and see if you think they're true or false, and then come back. So even numbers divided by 3, that is going to be false because we can come up with at least one counterexample. Because we know that, say, the even number 2 or 4, those are even numbers, but they are not divisible by 3. So we just had to have one counterexample to prove the statement is false. Now, we do know that there are 12 months in a year, so we know that's true. And then a triangle has 3 sides and 3 angles. We also know that is true. So now let's go through writing some compound statements. So the first one, we have P and Q. And if I'm going to write that in symbols, it would be P and then that upside down V and Q. And if I wanted to write this compound statement or conjunction together, again, I'm going to use my original statement and just join them with the letter and. So I can say even numbers can be divided by 3. I may use some symbols. Can be divided by 3, and there are 12 months in a year. So let's talk about the truth value in this. If we look at even numbers can be divided by 3, we already said that that was false. And then there are 12 months in a year, we said that was true. Now this is a conjunction, which means that both statements have to be true for the overall statement to be true. So because we have one false part, the whole thing is going to be false. So now let's look at the next example. So they tell us R or P. So that would be written R, and then because it's or, it would be like a V, P. So let's write this disjunction. So it would be a triangle, and I'm going to use some symbols, has 3 sides and 3 angles. I'm again use some symbols there. Or even numbers can be divided by 3. Can be divided by 3. So we had already said that a triangle has 3 sides, that statement is true. And we had said even numbers can be divided by 3 is false. Now this is a disjunction. So here, because just one of these is true, or at least one, then the overall statement is going to be true. Now, do you remember what the little squiggle means right here? It means not. So this is saying not Q, and the upside down V means and, not Q, and R. So let's talk about how we could write this. Not Q would be there are not 12 months in a year. And a triangle has 3 sides and 3 angles. So let's look at each one of these and see what the truth value is. There are not 12 months in a year is false. We know there are 12 months in a year. And a triangle has 3 sides and 3 angles. We know that's true. Now, because this is an and statement or a conjunction, they both have to be true for the overall statement to be true. So in this case, since we do have one part that's false, the overall part has to be false. Okay, so let's look at this last one down here. That little squiggle again means not. So we've got not P or R. So let's go through and write this. If it's not P, then what they're saying is even numbers are not divisible by 3, or a triangle has 3 sides and 3 angles. So let's look at the truth values. Even numbers are not divisible by 3. Can we come up with a counterexample there? Well, can't we have a counterexample of maybe 12? Could also do 6 or 12 or 18. There are a bunch of even numbers that are divisible by 3. So we know that part of our disjunction is false. If we talk about a triangle has 3 sides and 3 angles, we know that's true. Now, because this is a disjunction, we just need one part to be true, which in fact we do, which makes the overall disjunction true. So now I want to talk about actually making some truth tables. So here we've got a conjunction. It has P, and remember this right here is meaning and, P and Q. So we want to talk about what this looks like in a truth table. Now, when we are doing truth tables, it is really important when we put down our truth values for P, we are always going to use the same order of our truth values for P. And the truth values that we use for P are true, true, false, false. And again, we're going to come up with all of the possible truth values for Q to come up with all the different possibilities. So Q is going to be true, false, true, false. And so now we can figure out what happens if you have P and Q. Now remember, a conjunction is only true when both statements are true. So here we have P and Q are both true, so the overall conjunction is true. In the next row, the P is true and the Q is false, so the overall conjunction is false. The next one, we have one false and one true, so the overall conjunction has to be false. And then lastly, we have both of our P and Q are false, which means our overall conjunction is false. Now let's take a look at the disjunction. A disjunction, again, is going to use the word or. And or, if you remember, we just have to have one of our truth values to be true for the overall disjunction to be true. So again, we're going to fill in our column for P. That's just going to be true, true, false, false. And then our column for Q is going to be true, false, true, false. So then we want to look and see what happens if we look at the disjunction of P or Q. So if we have true or true, then our overall disjunction is going to be true. If we have true or false, we've had at least one true, so the overall disjunction is going to be true. And the same case for our third row. Now, if we look at our fourth row, we end up having two false statements. So we don't have anything that's true. So that overall conjunction, or excuse me, the overall disjunction has to be false. Okay, so I'm going to stop right here and you can follow the instructions in OneNote before moving to the next screencast.